Welcome back. We're continuing our study of solving linear simultaneous, because you have two of them, so we have linear simultaneous equations, and we're following along with the PDF I've given you for the Hailing book, okay, which is a graded exercise book, so we take one type of problem at a time and change the difficulty very gradually for you. So in this case we're looking at first question tonight was 9x plus y equals 3.5 and 6x plus y was equal to 2.5. So the first thing that stands out at us is this mixed numbers at the end. But both of them are essentially would be, if we doubled them, we would rationalize, we would turn them into integers, okay? We can bring them back into wholeness by doubling, and just doubling across through the equals. Just another little point is that the nature of both of these lines is that they're both decreasing, and the y is having the same effect in both ways. Now this could be quite deep and advanced, but when we want to eliminate by subtraction, you don't have in a y, when we were eliminating by addition, we would have had kind of the effect of y, we would have had an increasing and a decreasing line, and then through addition these are kind of ready to cancel each other out just simply by adding them together. So there's a kind of a correspondence to what's happening graphically. If the two lines are increasing or the two lines are decreasing, then we're thinking about what will happen is when we look at the algebra, it's likely that we will be eliminating by subtraction. So again, we must focus on the words and make sure you're able to explain your strategy. Eliminate by subtraction. And subtracting is something you've been doing for a long, long time. But it's nice to remind you that it's subtraction. And it's also nice to remind you that if you're to subtract two things that are equal, you can do it downwards or upwards. In this case, we're going to subtract it down. And we would subtract it down here. Okay? But just before I get into that, I would like to point out that while the subtraction will make this 1, we will then need to take a solution and substitute it in and go back into the dealing with fractions. That's not a good idea. So ahead of doing my subtraction, I'm going to do my doubling, which is double the entire system. These are balanced already, so any times 2 here will want to have a corresponding times 2 here in order to maintain the balance. So I'm going to go ahead and distribute this multiplication here. So it's essentially what I'm doing is 2 times 9x plus y with a distribution of multiplication, and over the far side I'm doing 2 times 3.5. But to build in that extra step is in the long run going to be counterproductive. It's okay to understand it right now and to explain it, but it's going to be counterproductive in the long run. So what you were hoping to do is lift your level of competency to the extent that you can just do this without explaining your distribution. So 2 of them is 18x. 2 of them is 2y. And 2 of them, multiplying across the equals, is 7. And furthermore, we get a 12x, a 2y, and a 5. Okay? And this becomes our new home, because when we're going to substitution, we're going to come back here. We're not going to see that again. We're not going to need it again. Okay? So now we go ahead with our subtraction. Now I always show addition with a double arrow and a subtraction with a single arrow. And after a while you can just get to know that this arrow means subtraction. To begin with, you might want to remind yourself you're subtracting. 18x take away 12x is 6x. Do not put anything there, because there's nothing there. Don't put naught there. 7 take away 5. Now notice that I'm subtracting in the same direction. It's important because subtraction is not commutative. Okay. So there's a highest common factor of 2. I'll take it out. Divide out the 2. This is an equivalent equation. It has the exact same solution. And the solution is the third. And that's going to be substituted now. We're finished with our elimination. Just say elimination ... is done. And now we're heading into substitution. Okay. So I'm going to use the top line. I'm going to go 18 times the number a third plus 2 times the unknown as of now, y, that we're trying to sort out, equals 7. Now the point is that what we now know is we had 2 lines crossing. Someplace there's an origin. Okay, and this was out 1/3. Because x equals a third is a line that goes along like this, with the x value of a third, the y value can be anything at once. So because we knew that we were on this line, we were able to use either of the other original lines to find the y value, which is what we're doing here. Okay, so we get to y on its own. Okay, isolate y, in other words. But there's a little bit of work to be doing first. 3 into 18 is 6. Plus 2y equals 7. Experience tells us that we should sort out, we should do the inverse of adding 6 first, because dividing by 2 can create fractions, and you want to leave that to the end. Okay, so the nasty thing about about coefficients is they have the potential to create a fraction, whereas the idea of a term, a constant term, lingering here, all I'm going to do is eliminate it by subtracting 6 from both sides, and that's not going to create a fraction. So you always go for the constant first, then the coefficient. You also always go for the addend, or the term, the plus minus term first, then you head into the factor, which has a completely different effect because that's multiplication and that's addition. So you get 2y equals 1 and y equals a half. And you're done, but you should always, as a good habit, to use the equation we didn't use before. We used this one for the x value. So you should substitute in x and y to this one to make sure that your solution is correct. So I get 12 times a third plus 2 times a half, separated from the number 5. It might be, hopefully it's 5. Well, that's 4 and that's 1 and that's equal to 5. So now I'm verified fully. And I can get my answer in a nice tidy form, in the form of a couple, which is xy equals a third, a half. Okay? So our next question is x plus y equals 3 and x plus 4y equals 12. Now the x's are ready to cancel by subtraction, and if I'm going to subtract, I'd like to subtract up, because it will be very, very convenient in both of those spots, here and here, in the y's terms and in the 12 in the constant terms, because you get 4y take y is 3y, and you'll get 12 take away 3 is 9, and y came out to be 3. Now I'll take my top line to fill in my y value, and I'll just write y is going back in there as a substitution. I get x plus 3, always bracket up your substitution, equals 3. They take each other out, leaving x equals 0. So once they've taken each other out, there's nothing there. Well, how do we represent nothing with a number? 0. So now I have an x and a y value, a y and an x value if you like. So I can put in the nothing. I can put in the 4 times 3, and it is indeed equal to 12, so we're verified. So xy equals 0, 3. That's your second answer there. And that was number 12. Going on to number 18 now. And we have 5x plus 3y equals 9. And 4x plus 3y equals 7. Now 5x take 4x is so what I'm doing is I'm seeing that the y's are going to go, the 3 y's are going to cancel by subtraction. I'll represent the subtraction that way. I get 5x take away 4x is x, and 9 take 7 is 2. I'll sub him here, getting 5 times 2 plus 3y equals 9, that's 10. So that's 10 here. Take 10 from both sides. Simplify, divide by 3. Okay, he's ready for substitution along with the 2. So I'll go xy here, putting in 2 a third. As we move along through here, these are in the right order. I'm getting 4 times 2 plus 3 times a third. Hopefully it's equal to 7. I might squiggle that until I'm sure. Ooh, that's alright. Look, that should be -1. Okay, and this is very important because it was a genuine mistake I made, a genuine slip, and that process, I went into silence. I should have kept talking to keep you going on my thought process, but what I didn't want to do is throw it all away. I wanted to see what was feeling wrong, and I worked out as far as 4 2s is 8, and I could see, well, that should have been, instead of +1 being a -1. So I homed in on the sign mistake. And you were probably, when you're watching the video, maybe kicking yourself and going, "No, that can't be right, go back, go back." And mistakes happen, and you do need to be able to have a system in place that can find it, and that's why we use our brackets for substitution, etc. So what I should have been writing here is y is equal to -1/3, ready for substitution, and then using this system and maybe using a pencil and an eraser, then you can quickly adjust your work and not run out of space when you have to correct your work. So you get 4 minus, now 3 into 3 is 1. So 8 minus 1 is indeed equal to 7, and we're verified. So only for the fact that I went and checked, I would have written down in the normal situation, if you weren't verifying, I would have written down 2 1/3. Totally unknowns to me, I wouldn't have got full marks. That's not a great idea. So you can see the value of verifying. It's not just a novelty. Okay, so another story here. I have my y and I have my x. 2 -1/3. Okay. Now moving to part 3, the difference in part 3 is its negative terms will be cancelling in general. Or are they mixed? There'll be various levels of extra challenge anyway. So this is part 3, question 6. Page 8, by the way. So I have 2x minus 4y equals 4, and x minus 4y equals 2. So of course, despite the fact that they're negative, they're both negative, but they're both the same. Both minus 4y's are the same, and things that are same eliminate by subtraction. So that's the idea. That's our concept going into this. Eliminate by subtraction. So basically by subtracting it would go minus 4y minus 4y, which is plus 4y. So we don't have to worry about that, they're going to go. We need to think what direction we want to cancel, subtract in, and let's subtract it down. 2x take away x is x, 4 take away 2 is 2, that's ready for substitution. We'll sub them in here. Put a bracket on the x there to say I'm subbing in the x. And we start off here 2 times 2. The x has been replaced with 2. Minus 4 times y equals 4. Take out the common 2. Will I cancel that one? Will I cancel that one? Doesn't matter. Okay, so that's 2 minus 2y equals 2. I could have just gone to 4's, take each other out. Now where does that leave us? It leaves us with minus 2y equals 0. Okay, so y plus 2y equals 0, because the negative version of 0 is 0, and y equals 0 over 2, but that's 0. Okay, he's ready for substitution, just to be sure. So we go here and start subbing, and this will normally done over time. You'll develop this to be a mental operation, just to make absolutely sure. And so going, that is my 2. I'll write it down, but it will eventually become mental probably. Minus 4 times 0 is indeed equal to 2, and we're happy with our solution. So just write it up as a couple. X, y equals 2, 0. Okay. 2 to go, and then your homework's done.